Hi everyone, Tina here, and today I'd like to talk about prime factors, HCF or highest common factor, and LCM or lowest common multiple. You'll need to know about these ideas for both the Foundation and Higher GCSE maths courses. I'll run through what these ideas are and then we'll look at some examples. First of all, what is HCF and LCM? HCF stands for highest common factor. LCM stands for lowest common multiple. If we think through these ideas, starting with HCF, let's say we had the numbers 10 and 25, and we want to know what is the highest factor that they share in common. So if we think about the factors of 10, those are numbers that go into 10, that will be 1 and 10 as a pair, and then also 2 and 5. Doing the same thing for 25 would be 1 and 25 as a pair, and then 5 and 5, so just 5 as a factor of 25. In terms of the ones they share in common, they both share 1 and they both share 5. So just thinking through this one, the highest common factor would be 5. Let's think through LCM for the same numbers, so for 10 and 25. Now, in terms of multiples of 10, that's the 10 times tables, we've got 10, 20, 30, 40, 50, 60, and so on. And for 25, we've got 25, 50, 75, 100, and so on. We're looking for any multiples they have in common, and particularly the lowest one. So we can see that they both have 50. And that is the lowest common multiple. Now we know what HCF and LCM are, I'll show you my preferred method for working them out. You can do the method I just showed you, but that will become difficult when the numbers get larger. I'll show you the method for 10 and 25 first, so you can see how it works for these smaller numbers, but then we'll apply the method to some bigger ones. So the method involves using a prime factor tree and a Venn diagram. So for 10, if we break that down into its prime factor tree, we can say that 10 is made up of 2 and 5, and both the 2 and 5 are prime, so we can circle them. And that means underneath, we can say 10 equals 2 times 5. This format is sometimes referred to as the product of prime factors. Remember, product just means times. For 25, if we do a similar factor tree, that's 5 times 5, and 5 is prime, so we can circle it. Therefore, 25 equals 5 squared, or 5 times 5. Once we have these written out, we're ready to look at our Venn diagram. So we draw a Venn diagram. One circle can be for 10 and the other circle can be for 25. And then we sort the factors out into the Venn diagram. So first of all, looking for any factors that they share in common. And they both have a 5. 10 has 1 5 and 25 has 2 5s. So we put a 5 in the middle and an extra 5 for 25. The only factor left that we haven't sorted yet is 2. So we put a 2 in the 10 circle and then we're done. Once you have your Venn diagram, the HCF is any numbers that are in the overlapping part of the Venn diagram. In this case, the HCF is just equal to 5, just like we found out before. And you get the LCM from timesing all the numbers in the Venn diagram together. So in this case, the LCM is going to be 2 times 5 times 5, so 2 times 25, which equals 50. Now I'll show you this method for some bigger numbers. So here we want to find the HCF and LCM of 84 and 120. So starting with our prime factor trees, you can split 84 however you like, but I'm going to choose 2 times 42 to start with, circling 2 because it's prime. I'll split 42 down into 6 times 7. 7 is prime, and then 6 down into 2 times 3, both prime. So we can say 84 equals 2 squared times 3 times 7, because there are 2 2s, 1 3, and 1 7. You can write these numbers in any order you like, but I like to order them smallest to largest just to make the Venn diagram part a bit easier. Let's do 120 now. Again, split it however you like, but I'll do 10 times 12. 10 is 2 times 5, and 12 can be 2 times 6. 6 breaks down into 2 times 3. So we can say 120 equals 2 cubed this time, because there are 3 2s, times 3 times 5. Now we're ready for our Venn diagram, and let's sort the factors. So 84 and 120. Any factors they share in common go in the middle. So they both have 2s and they both have at least 2 2s. So we'll put 2 squared in the middle, deals with that. And then for 120, looks like there's an extra 2. They both share 1 3, so that can go in the middle. And then 84 has an extra 7 and 120 has an extra 5. To get the HCF, remember we look at the middle overlapping part and we times any numbers that are in the overlap together. So HCF in this case will be 2 squared times 3. Working that out would be 4 times 3 or 12. So 12 is the highest common factor for 84 and 120. Let's do LCM now. So we want to times all the numbers in the Venn diagram together. LCM is going to be 7 times 2 squared times 3 times 2 times 5. You can do the multiplications in any order you like. So I'm going to do 7 times 12, which takes care of the 2 squared times 3, times 10 for 2 times 5. This is the same as 7 times 120. And then if we work that one out on the side, 120 times 7 is 840. So the LCM is 840. Now, sometimes HCF and LCM questions can be hidden inside a worded problem. For example, this one, Lily is making party bags. She has 60 balloons and 48 lollipops. She wants to use them all. Each type of item must be shared equally among the party bags. What is the maximum number of party bags she can make? Now, we might notice that 6, for example, goes into both 60 and 48. So we could think about maybe making 6 bags, and those bags would have 10 balloons in and 8 lollipops. But there might be a larger number of bags we can make, and this is telling us that we've got to look for the highest common factor, or HCF. So let's use the method we just saw. So let's break 60 down into its prime factors. For example, 6 times 10, and then breaking that down further. So 60 equals 2 squared times 3 times 5. And then 48 can be split down as well, meaning 48 equals 2 to the power of 4 times 3. We can use our Venn diagram and sort out our factors. Both have at least 2 2's, so 2 squared in the middle, and then an extra 2 2's for 48. Both have a 3, and then 60 has an extra 5. This time we're only interested in HCF, so we're only interested in that middle overlapping part. And in this case, the highest common factor would be 2 squared times 3, which is 4 times 3, or 12 party bags. So she can make double the original 6 bags we thought of and still have an equal spread of both balloons and lollipops. Example 3, another worded problem. This time it says a blue light flashes every 8 minutes, whilst a pink light flashes every 54 minutes. Both lights flash together at 2 p.m. When is the next time that both lights will flash together again? Now again, it might not be obvious that this question is in fact about LCM, so I'd recommend you just think it through first. So this blue light is flashing every 8 minutes. So 8 minutes, 16, 24, 32, and so on. Whereas the pink light is flashing every 54 minutes, so 54, 108, and so on. Hopefully working this through will make you realize that in fact you're looking for the lowest common multiple. So when is the next time that they will flash together again? What is the next multiple that they share in common? As soon as you've identified that you want to do LCM, you can go ahead and do your method. So the prime factor tree for 8 is pretty small, 2 times 4, and then 2 times 2. So 8 equals 2 cubed. 54 can be broken down. So 54 equals 2 times 3 cubed. Venn diagram time, 8, 54. They share 1 2 in common, and 8 has an extra 2 2's. And then 54 has 3 3's. This time we're only interested in LCM, so let's find that by timesing everything in the Venn diagram together. LCM equals 2 squared times 2 times 3 cubed. 2 squared times 2 is 8. 3 cubed is 27. Working that out gives us 216. So the answer is going to be 216 minutes. However, the question wants to know the exact time after 2 p.m. that the lights will flash together again. So let's put 216 minutes into hours and minutes first. To do this, we can think about the fact that there are 60 minutes in an hour. So 60 for 1 hour, 120 for 2 hours, 180 for 3 hours. So 216 will be 3 hours and then 36 minutes. Because you need another 36 minutes to get from 180 to 216. After 2 p.m., adding on 3 hours and 36 minutes will take us to 5:36 p.m. And that's the final answer. Last example, I wanted to show you that this method also works for 3 different numbers in a 3-way Venn diagram. This time, they've already given us the numbers broken down into their prime factors, so we don't need to do that step. We can just go ahead and make a 3-way Venn diagram, one circle for 20, one for 45, and one for 120. And we can go ahead and sort out the prime factors which were given to us. So all 3 numbers share a 5. So 5 will go right in the middle of the 3 circles. And if you look carefully, 20 and 120 share 2 2s. So we can put a 2 squared in there. That deals with this, but then 120 has an extra 2, so that's dealt with now. And then 45 and 120 both have a 3 in them. They share 1 3, and 45 has an extra 3. Once you have your Venn diagram, you just choose the parts that you need. So for HCF, we just want the overlapping part. And in this case, there's only one number in there, just 5. So the highest common factor will be 5. And then for LCM, remember we want to times everything together. So in this case, LCM will be 2 squared times 2 times 5 times 3 times 3. Again, doing the multiplication in whichever order you like. 2 squared times 2, that's 8. Times 5 times 9. 8 times 5 is 40, and 40 times 9 is 360. So the LCM is 360. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else who you think might find it helpful. Thanks, and see you next time.